All right, so a continuation of 5.1. So we're going to look at 5.2. In 5.2, we are going to talk about polynomial functions and adding and subtracting. So basically, we're just going to be combining like terms. But now we're going to talk about defining what a polynomial, a monomial, a binomial, a trinomial, and a degree. Okay, so basically, just like before when we talked about terms, a term is a number or product of a number and variables raised to powers. Coefficient is the numerical factor term, so the number that's in front of your variables. A constant, a term which is only a number, meaning there's no letters involved, it's just a number. And a polynomial is a sum of terms involving variables raised to a whole number power exponent with no variables appearing in any denominator. All right, so what that's going to look like is, here's your vocab. So in the polynomial, 7x to the fifth plus x squared y squared minus 4xy plus 7. All right, so let me get my pen going here. All right, so there are 4 terms. We have 1, 2, 3, and 4. So this has 4 terms. The coefficient of 7x to the fifth is 7. The coefficient of x squared, y squared is 1, because remember there's that assumed 1. The coefficient of negative 4xy is negative 4, and the term of 7 is 7. 7 is a constant. Okay, so a polynomial. So a polynomial is in x is a finite sum of terms of the form ax to the n, and I don't know why that is not an exponent. Let me fix that. All right, so a is a real number and n is a whole number. So in other words, a polynomial is the sum. Okay, so it's the sum of terms. So if we go back and look at this example, 7x to the fifth plus x squared y squared minus 4xy plus 7, this is a polynomial. It's a sum of terms. Okay, so now a monomial only has 1 term, a binomial has 2, a trinomial has 3. Anything more than 3 terms is referred to as simply a polynomial. But these 3, 1, 2, and 3, have more specific terms. So find the degree of each polynomial and tell whether the polynomial is a monomial, a binomial, a trinomial, or more. So for example, 9y squared plus 3y minus 7. This is a trinomial, and it has a degree of 2 because the largest exponent is 2. The term, or the polynomial, 6x plus 4x cubed plus 5x squared minus 3, this degree of this polynomial, it's polynomial because there's more than 3 pieces, is 3 because the largest exponent is a 3. Now, if we were to look at this polynomial, 7x squared y minus 6x squared yz plus 2 minus 4y cubed. It says determine the degree of each term. So this x has a term of 2 and the y has a term of 1, so it has a degree of 3. X squared, y to the 1, z to the 1, 2 plus 1 is 4, so this term has a degree of 4. This term has a degree of 0 because there are no variables, and this has a degree of 3 because only y has an exponent. So that's how you figure out the degree. You just count the just add up the sum, get the sum of the exponents for each term. Okay, so now defining them. So if p of x equals 3x squared minus 2x minus 5, find the following. So if p of 1, so in other words, they're saying that x is 1. So what you want to do is everywhere you see an x in your polynomial, you're going to replace it with a 1. So p of x will become p of 1. This is 3, 1 squared, minus 2 times 1, minus 5. And it's going to equal negative 4. Because we've got 3 times 1 squared is 1. minus 2 minus 5. 3 times 1 is 3. 3 minus 2 minus 5. 3 minus 2 is 1. 1 minus 5 is negative 4. So that is where the answer comes from. Now, if I do the same thing and everywhere I see an x, I plug in this negative 2, I'm going to get 3 times negative 2 squared, so it's negative 2, which is 4, minus 2 times negative 2 minus 5. And they're telling us the answer is 11. I'm going to show you why. 3 times 4 is 12. Negative 2, so here we got minus 2 times negative 2, so negative 2 times negative 2 is 4 minus 5. 12 plus 4 is 16 minus 5 is 11. So that's where the answer comes from. Just have to plug in the value of x and then follow your PEMDAS rules. All right, so here's an example using our word problems. So the Swiss Re building in London is a unique building. Londoners often refer to it as the Pickle Building. The building is 592.1 feet tall. An object is dropped from the highest point of this building, so from here, so we're standing at the very top of the building. Now, if we neglect air resistance, the height in feet of the object above the ground at time t, seconds, is given by this polynomial. Negative 16 t squared plus 592.1. It's starting here. So if you think about where you're starting at 592.1 feet in the air. And your nickel is falling at negative 16 t squared. So find the height of the object when it's been falling for 2 seconds, and again when it's been falling for 4 seconds. So what we're going to do is we're going to, everywhere we see a t, we're going to replace it with a 2. So 16 times 2 squared plus 592.1. So negative 16 times 4 plus 592 is 528.1 feet. So in other words, if you're standing on the top of this building here and you drop a nickel, so the height of the building is 592.1. After 2 seconds, so you drop this nickel, and after 2 seconds, the height of the nickel is now 528.1. After 4 seconds, so now the nickel is here before it hits the ground, okay? So now it is 336.1. So now it's at 336.1. So plugging in that 4 seconds where you see the t, and that's how you're able to find. So if I wanted to know where it was at another time increment, I would just plug in that time in place of t. Now, what if I wanted to know how long it took it to hit the ground? So if you think about when it hits the ground, all of this is giving you the height. Okay, so the height after 2 seconds is 528. The height after 4 seconds is 336. Well, if it's on the ground, the height would be 0. So here, that's 592.1. If I wanted to know how long it took, then I would solve saying that the height was 0. And so then you would have to work backwards, which we will get to that, but I just want to make sure that you're not plugging in your numbers here. All right, so we're going to combine like terms. Again, it's the same thing we did before. You combine what looks alike. So here I have negative 6y plus 8y. So since they both have a y, then basically you're just saying, what is negative 6 plus 8? Negative 6 plus 8 is 2y. Okay, here, take inventory of what you have. So I see that I have a y squared and another y squared. I have some whole numbers. So if you group them together, so your 14y squared minus 10y squared plus 3 minus 9. Remember, you're always going to make sure you're using the sign that is in front of the term. So 14 minus 10 is 4, and 3 minus 9 is negative 6. Here, don't forget that there is an assumed 1, and since they both are just x cubed, it's just 7 plus 1. 7 plus 1 is 8x cubed. So you're just combining things that look alike. All right, simplify each polynomial by combining like terms. So if I look at this term here, I see this is an x squared. So I'm going to put this, and then I have negative 6x minus x minus 15. So since there's no more x squareds, that's not going to be added to anything, so it's just by itself. However, this negative 6 and this minus 1, so negative 6 minus 1 is negative 7, and then the 15 is by itself, so it doesn't get added to anything either. Okay, now looking at this, I have an x cubed here, and I have an x cubed here. I have an x here, and an x here, and then I just have this plain old 2. So if we combine them by using our rules of fractions, getting your common denominators, so I would have 2 over 7 minus 1/2. Since they both have an x cubed, I can combine them, okay? So I'm going to multiply this by 2 over 2. So that's going to be 4 over 14 minus, and I'm going to multiply this one by 7. That's 7 over 14. So that gives me negative 3 over 14. So I should have, so here we're taking, oops, let me move this over here. So here you're grouping your 2 over 7, you're grouping your x's and so on. So I didn't group them together over here, I just kind of jumped in. So we got 4 over 14 minus 7 over 14, which is what I got, which is going to bring us to negative 3 over 14 x cubed. These, since 4 can turn in, I'm going to multiply by 2 because I can turn the 4 into an 8. So this becomes negative 2/8. So negative 2/8 plus 3/8 is 1/8. And then you have your 2. So this is your final answer. Even as awkward as it looks, that is your final answer. You can't combine anything else because nothing else is alike. But you have to make sure you're using your rules of fractions. So if I combine these like terms, go through and look. So I have x squared y, and then here is an x squared y, and there's no more. Now I have an xy and an xy. Here's just a y, and here's just a y. So take and group your things together. So here's the x squared, y squareds. Here is your xy's, and then here is your y's. Okay, so 10 plus 1 is 11. xy plus xy, that's 1 plus 1, so that's 2. And then negative y minus 2y is going to be negative 3y. And this would be your final answer. You can't combine it any further because the exponents don't match on your variables. All right, now when you're adding and subtracting them, it's still just called combining like terms, but you have to be careful, okay? Now, if I'm going to take this term, 3x plus 8, and I'm going to add it to this term, this binomial, and add it to this trinomial, then you're going to remove the parentheses. So as long as this is a plus sign, you just remove the parentheses, nothing changes. So now I have 3x minus 3x, so those two are going to cancel out. I have a negative 8 plus 3, and then I have this x squared, which doesn't have anything else. So if you group them together, so you got your 4x cubed here, then you have your 3x minus your 3x, and then your negative 8 plus 3. And you wind up getting 4x squared because it doesn't add to anything. Remember, those 3x canceled out, and negative 8 plus 3 is negative 5. And that is your final answer, which looks much more simple than this, which is the whole point of combining like terms, is to reduce the number of terms so that it's easier to look at. All right, so it says to add 8y cubed minus 4y squared plus 5 and 5y squared plus 1 using a vertical format. Some of you may like this better because what you do is you line everything up. So you take the first thing, which is 8y cubed minus 4y squared plus 5, and using vertical, so remember vertical is going up and down, and you add this to it. So you put it underneath. You put your y squareds together, you put your numbers together. This just drops down because there's nothing to be added to it. Negative 4 plus 1, or sorry, negative 4 plus 5 is 1, and then 5 plus 1 is 6, and that is your final answer. This format is fine too. It's a matter of what works best for your brain. To subtract polynomials is where you have to be very careful, okay? You have to be careful because of the subtraction sign. All right, so here we have 4 minus parentheses negative y negative 4, okay? So remember, that's like saying there's an assumed 1 right here. So you're going to need to distribute that negative sign to everything inside the parentheses. So what happens when you do that is that negative y times negative becomes positive y. The negative times the negative becomes positive 4. So now I can combine things that are alike. Y is by itself, and then I have 4 plus 4. So your final answer is y plus 8. All right, so let's do it one more time. So I have 7x minus 8 minus 3x minus 12. Since the minus sign is outside the parentheses, I need to distribute that negative sign to everything inside the second set of parentheses. So you wind up getting, let's see, we're going to not look at it like that. So we're going to do this. We'll just do it this way. Sorry. So we're going to remove the parentheses on the first one, 7x minus 8. And then we're going to distribute this negative sign. So that becomes minus 3x plus 12. Now in this step, we're going to have 7x minus 3x because those terms are alike. Then minus 8 plus 12 because those are just numbers. 7x minus 3x is 4x. And negative 8 plus 12 is 4. And there's our final answer. All right, here we go again. So we have 2x cubed plus 8x squared minus 7x minus 3x cubed minus 2x squared plus 3. So we're going to distribute that negative sign to all three pieces. So the first set of parentheses, we just get to drop them because there's nothing in front of them. Negative x times 3, or sorry, negative times 3x cubed is negative 3x cubed. Negative times negative is positive 2x squared. Negative times positive is negative 3. So now take inventory of what you have. So I have this 2x cubed and a negative 3x cubed. 2 minus 3 is negative x cubed. I have an x squared and an x squared. 8 plus 2 is 10x squared. Then I have this just an x by itself, and I don't have any more, so you just bring it down. And then I've got this negative 3 by itself, so you just bring it down. And then you're left with a 4-term polynomial of degree 3. All right, so you can add and subtract binomials and trinomials, and everything always works the same. Always make sure you're looking at what is in front of the parentheses. In front of this set, there is nothing, so it's negative a squared plus 1. This set of parentheses has a negative sign in front of it, so I need to change the signs because I am distributing a negative sign. This set has a plus sign in front, nothing changes. plus 5a squared minus 6a plus 7. Now combine your terms. I have negative a squared, I have another negative a squared, and I have a 5a squared. So 5 minus 2 is 3a squared. Let's see, look for the next term down, which would just be an a. So here I have a negative 6a, and there are no other a's, so I'm just going to bring it down. And I have 1 plus 3, which is 4, and 4 plus 7 is 11. And there is your answer. You always want to start with the largest exponent and go down in increments. Okay, you want them to be in numerical order going down, so you want descending order. All right, add or subtract. Okay, there is nothing in front of this set of parentheses, so I'm just going to rewrite it. 3x squared minus 7xy plus 8y squared. This set has a plus sign in front, so again, nothing is going to change. Minus 2x squared plus 9xy minus y squared. Take inventory of what you have. I have a 3x squared, and oops, that's a y, and a negative 2x squared. So 3 minus 2 is 1. Now I've got a negative 7xy and a positive 9xy. So negative 7 plus 9 is 2xy. And then I have this 8y squared minus a y squared. So 8 minus 1 is 7y squared. And there's your final answer. This is a trinomial, and it has a degree 2. So it's pretty simple. Just make sure that when you have these parentheses, you're looking in front of the parentheses to see if it's a positive or a negative, so that you know to distribute or not. All right, so we got 9a squared b squared plus 7ab minus 4ab squared minus 6b squared a plus 3ab minus 4 minus 10b squared. So the first set of parentheses, there's nothing, so I'm just going to bring it down. 9a squared b squared plus 7ab minus 4ab squared. This set has the negative in front, so we're going to distribute. So negative 6b squared a, negative 3ab, this negative 4 will become positive, and this negative 10 will become positive. So now take inventory of what you have. So I have 9a squared b squared. So look for a squared b squareds. There are no more a squared b squared, so I'm just going to bring that down. Okay, now I have a 7ab. There's a 3ab. And so 7 minus 3 is 4ab. All right, now I have a negative ab squared. This is also ab squared. The order of the a and the b doesn't matter as long as the exponents match. So negative 4 minus 6 is negative 10 ab squared. So these two, the b squared and the a, can change places. Okay, then my next piece is I have this b squared here. So if I were to look at the b squared, there's no more b squared, so I'm just going to put 10b squared. And then you have a 4 left over, so we'll just add that to the end. And I will add that in a different color because there's nothing to add to it. And that is your final answer. This is a 1, 2, 3, 4, 5-term polynomial, and the degree is 4, okay, because this has 4 pieces. All right, and that is the end of 5.2. I will be getting 5.3 shortly.